Hi, everybody. Welcome to my talk. In the schedule, I think it's called something really boring, like refactoring components. But one of my colleagues pointed out to me that I was really missing out on the opportunity to name it something like getting on the refactor tractor. So that's what we're going with. My name's Erin. You can get me on Twitter at Erin Zimmer. I work at Cash App, which you may not have heard of because the product isn't actually available in Australia. But apparently we're pretty big in the US, where we provide banking services to people who aren't able to access the sort of standard banking system in the US, because apparently it's a bit more complicated over there than it is here. We also offer banking services to regular people, and we have a bunch of really cutting-edge, exciting features like being able to buy and sell stock, being able to buy and sell Bitcoin, and being able to transfer money instantly, because apparently that's not a thing in the US. I am a Google developer expert, and I like to knit. So if you see many talks here, I'll probably be knitting. Is there any other knitters in the audience? No? Oh man, you don't know what you're missing out on. And if you would like to play along at home, the slides are available at refactortractor.ez.codes. Okay, cool. So what are we going to talk about today? We're going to talk about refactoring, funnily enough. We're going to talk about what it is and when we should do it. We're going to talk about how we can make sure that we're doing it safely. We're going to look at some additional things we should think about with JSX. And we're going to do a bunch of live coding examples because I like to live dangerously. All right, so let's start at the top. What is refactoring? So refactoring is when we change the implementation of our code without changing the functionality, right? So we change how the code is written without changing what it does. So we might do things, we might do this because we want the code to be easier to understand, we want it to be easier to test, or because we want it to be easier to change later. The kinds of things that we might do while we're refactoring are things like renaming variables. So perhaps the code has changed a bit, the variable names are no longer really accurate, we can update them to make the code a bit easier to understand. Or they might have typos in them. We always need to fix that, right? We might do things like splitting up a long function into smaller functions, right? So if we have a long function that has lots of low-level detail in it, we can split that low-level detail out into other functions. So we now have a short function with high-level detail. So this makes the code easier to understand, and it also makes it easier to test because we can split things out and test all the different scenarios. We also might do things like factoring out repeated code. So if we've got repeated code and we need to make a change, then we need to make that change in multiple places, so we can factor it out into a single place, and then our code is easier to change in the future. If you're interested in like the deep down details of refactoring like this, you should check out Martin Fowler's book, Refactoring. He has like a whole list of different moves that you can make to refactor code and like how to do them and when to do them and that kind of thing. We're not going to go into that kind of level of detail today, though. Okay, so we know what refactoring is. We need to decide when we want to refactor. And the answer to that is when the benefits outweigh the costs, which is obviously a complete cop-out answer because that's when you do anything. So to think about that, we need to think about what are the benefits and the costs of refactoring. So the benefits of refactoring, the major benefit of refactoring is that we can build stuff faster in the future, right? It makes the code easier to change, easier to update. It's going to be easier to build a new feature in the future. The second is that we often end up with less bugs, right? If we refactor the code so that it's easier to understand and easier to test, then we usually end up just putting less bugs in it. And the third reason people often refactor is that it's a lot of fun. I don't know about you, but I really love getting in and cleaning up a code base. So that's definitely factors in sometimes. But it's important to remember that there are some costs associated with this as well. And the biggest cost of refactoring is time. So every hour that we spend refactoring code so that it's nice is an hour that we're spending not building a new feature. And it turns out, for some reason, users don't really care what the code base looks like. They're mostly interested in features and not having bugs and trivial stuff like that. There's also some risks associated with refactoring. So I found this delightful haiku on Twitter. This is another Erin, it's not me. There are more than one of us. And she says, "This code used to work. Hey, I should refactor it. Now, it does not work," which I think is probably a sentiment that's pretty relatable. Obviously, she posted this on Twitter, so she got a bunch of men just replying saying, you should write some tests. But it's not always that easy, right? When you're working with legacy code, it's not always obvious what the original intent was or what the code is supposed to be doing. And it's not even that, right? There's not even just the risk of putting bugs in the code. There's also a risk of fixing bugs by accident. And that might not sound like a bad thing, but if you've got bugs in your code that have been there for a while, and you've got users who have workarounds to those bugs, then fixing them can be very disruptive for them. As an example, I'm sure we are all well aware that last week was the end of life for Internet Explorer. And Internet Explorer was a piece of software that had a lot of bugs in it. And some of that was just because, I don't know, Microsoft didn't want to put in the effort to fix it. But a lot of it as well was that they'd put these bugs in. People who built websites relying on these bugs. And if Microsoft went and fixed all the bugs in Internet Explorer, then thousands of websites around the world would break, right? So yeah, when we're refactoring code, we have to be sure not to change it, both in terms of not putting bugs in and also not accidentally taking bugs out. As an example of some code that I did not refactor, there's this. I hate this function. This upsets me a lot, right? This should be one line. There's no reason for all of this. But this was in a code base that I was working on last year, and I looked at it every day for like 2 months. I scrolled past it, and I hated it, and I didn't refactor it because it works, right? It works. It's easy to understand. It would have been easy to test if the person who wrote it had bothered to write tests for it. There's sort of nothing wrong with it, and I wasn't changing it, so there was no value in refactoring it. So as far as I know, this is still in the code base to this day, but I don't have to look at it every day anymore. Okay, so my general rule of thumb for refactoring is that I only refactor code if I'm about to make a change to it, or I know someone else is about to make a change. And the reason for that is that if I'm about to make a change, then I know that my refactoring is going to provide value, right? It's not going to be a waste of time. But also, if my team is working on this bit of code, then there's eyes on the code, right? There's people who are solving problems in the same area. There's people who know how this code is supposed to behave. There's people who are going to notice if it changes. Other developers who are reading my PRs are going to have a better idea of what it's supposed to be doing. There's probably going to be designers and product people who are looking at the product as well. Maybe even testers, if you've got testers. There's going to be, people are going to be more likely to notice if something inadvertently changes. And also, we're doing a change anyway, so we can probably get away with some extra little changes if it happens. Okay, so let's say we have decided that we're going to refactor some code. Our code base is using Moment.js, which is a date time library, which you might be familiar with. Moment.js was like the cool date time library several years ago. But these days, it's generally not recommended to use it. There's a lot more modern alternatives, and I, for one, am really sick of our code base having bugs in it because of the mutable date times that you get with Moment.js. So we've decided we're going to refactor. This is the function that we're going to refactor. It's just basically taking a date and returning a formatted string, right? So it's giving us a way to have consistently formatted date times throughout our whole code base. Okay, so what should we do? We decided to do this refactor. I like to follow sort of a 3-step process. The first is that we're going to use tests to determine the current behavior. Then we're going to go and refactor the code. And then we're going to go and do our actual change. Now, for this demo, we're not going to do the change. I'm sure you all know how to do a change in code. We'll just do the first 2 steps. All right, so the first step is to write tests to determine the current behavior. And the kind of tests that we can use to do that are a special kind of test called characterization tests. Characterization tests come from this book, Working Effectively with Legacy Code by Michael C. Feathers. If you are working with legacy code and you would like to do it effectively, I recommend having a look at this book. But for today, we're just going to look at characterization tests. So characterization tests differ a bit from the normal tests that you would write when you're building features. So if we're writing a test for a feature, first of all, we write a test with some expectations, and then we write some code that makes the test pass, assuming you're doing TDD. If you're not doing TDD, I don't know, I assume you write some code that's wrong, and then you write some tests, and then you change your code until it's right. And I don't know what you're doing with your life, but that's your choice. With characterization tests, it's kind of the other way around. We start with a test with no expectations, and then we change the test until the test passes. So with feature tests, the code changes, but the test stays the same. With characterization tests, the test changes, but the code stays the same. The important thing here is that we're only ever changing one or the other, right? We're either changing the code or we're changing the tests. We're never changing both at the same time. Okay, let's see what that looks like in practice. So here we have our format date function that we're going to refactor. So we're going to start with writing a test. Now we've got a few scenarios that we need to test here, but the first thing that I always like to start with is the most basic kind of input we can give it, which is nothing. So when we pass in nothing, now here we don't actually know what it's going to do, so let's just put a placeholder there. So we can write our test. We're going to expect format date and pass it nothing to be, and again, we don't know. So we can run that test, and we see that it fails, which isn't surprising because it would be a bit weird if our format date function returned question mark, question mark. But we can see that what it actually returns is an empty string. So we can update our test here, and we can update the description, and we can say it returns an empty string. Cool, so we've got our first characterization test, which should now pass. Then we have a couple more scenarios that we need to write, because we need to cover all of the kind of inputs that we can pass into that date constructor, which is a date, a string, or a number. So when we pass in a date, we don't know, again. And we need to pass in a date. And when I'm testing things like this, I like to use a date that has the month and the year below 10, so we can see what it does with the padding. So let's just go something really boring. 1st of January 2020. Remember the 1st of January 2020, back when we thought the world was fine? And we run that, it fails, because it turns out that it actually returns a formatted string. So we can stick that in there, and we can say it returns a formatted date. Okay, so the next scenario we need to test is strings. So we can say when we pass in a string, it returns a formatted date. I mean, that's probably what's going to happen. I'm not going to go through the whole making it fail and then making it pass, because it'll be boring. So let's just make that one pass. But with strings, there's a couple of edge cases that we need to test as well. So one is if we pass in a string that looks like a date but isn't really a date, what I'm going to call an invalid date string. So something like if we passed in the 30th of February, then what's it going to return? It turns out it converts it into a valid date. So that's fine. We can grab that. Oops. No, what are you doing? You know what? I'll just type it myself. What is it? 4, 3, 1. Okay, it returns a formatted date. And the other thing we can do is pass in a string that just totally isn't a date at all. An invalid string. We don't know what it's going to do this time. And we're not going to pass it a date. Instead, we're going to pass it a sultana. Yeah, okay. And what's that one going to do? In this case, it's going to return us this string invalidate. So we can grab that. And we can see here, it returns an error message. Cool. So that just leaves passing in a number. So we can do that. Yeah. Now, when we pass in a number to the date constructor, it represents the number of milliseconds since midnight on the 1st of January 1970. So we can convert this date here into a number by just going get time, and it should just give us the formatted string. And when we're testing with numbers, though, there's two edge cases that I always like to check. One of them is if we pass in a negative number. In this case, a negative number should represent a date before the 1st of January 1970. So we can just change this to like 1960. And it's almost certainly not going to return this. And we get our fail, and we get another formatted date. And the last one that I like to test is 0. When we pass in 0, we're going to expect that it will return a formatted date. And let's see what that does. Turns out it fails, but it doesn't return a formatted date. It actually just returns empty string. The reason for this is that in our function here, we've got this little catch at the top, which presumably is there to catch undefined or null or empty string. But because of the way that falsy values work in JavaScript, it also catches 0 and then returns empty string. Now, this is a bug. And it would be a bug that would be pretty easy to fix, but we're not going to fix it, right? We're here to refactor. We don't want to change the behavior of the code. Instead, we'll write a card and we can prioritize it later. And the reason for that is even in this sort of minor case, this formatting function could be used across the code base all over the place, and it's possible that someone else has been using it and noticed the bug and written some code as a workaround for that. And fixing the bug isn't going to break their workaround, but it does going to make their workaround stop making sense, right? It's going to be code that's just floating around there that doesn't do anything, and the next person who looks at it is going to be, why have they done this? So it's a good idea if we are going to change the behavior of this to go and check and make sure. Again, for something this trivial, maybe you wouldn't worry about it, but the principle is there. Okay, so what we're going to do instead is we're just going to document it. We're going to say when we pass in 0, it returns an empty string. An empty string, and we're going to update this. Okay, and now we run our tests. They all pass. And that, to me, is enough tests for our characterization test. You could argue that we could write some more tests, that we could cover some more cases, so things like passing in null, passing in a Boolean value, which would actually be interesting, because if you passed in a Boolean, if you passed in true, it would return invalid date, but if you passed in false, it would return empty string, which is weird, but not as weird as passing a Boolean into a formatting date function. I personally wouldn't worry about writing those tests for two reasons. The first is that if this was production code, I would use TypeScript, and it would no longer be a problem. And the second is that honestly, if people are passing Booleans into date formatting functions in your code base, you've got bigger problems to deal with. Okay, so now we've got our tests. We're all happy. We'll commit to Git, and we're ready to actually do our refactor. So in this case, we're going to change moment. We're going to replace it with the format function from the date functions library, which is not that one. It's that one. And it takes a date, just like this one, and a formatting string. But because this is JavaScript, obviously, the date functions people couldn't use the same formatting strings as the moment people. So we'll just update that one. Okay, we can run all of our tests again, and we can see they all pass except for one. And the one that fails is the invalid, when we pass in the string that isn't a date at all. The date functions function actually throws an exception, which you could argue is the better behavior, and I would probably agree with you. But again, we're not here to change the behavior of this function. We just want it to work exactly the same. So we can wrap this in a try catch. and we can just return invalid date. And all of our tests pass. So we've done our refactor, and then we could go and do whatever other changes we need to do. So are we all okay with that? Yeah, cool. You might argue that writing like 8 tests to test 4 lines of code is kind of overkill. And yeah, sometimes it is. If this was a date formatting function that was used in a single component and nowhere else in the code base, then I probably wouldn't write all of these tests for it. I would probably just write the tests for the things that I know can happen. But I recently actually did a change like this in our code base, and the date formatting function that I was refactoring was used in, I think, 600 different places in the code base. And to me, 8 tests for 600 different usages seems okay. Also, like, you saw how long that took, right? It was like 4 minutes or something. All right, so, oh, we need to change back to slides. That's not going to work at all. Nope, nope, nope. Okay, so we've done all of that. We're all happy with how to write characterization tests, but how do we do it with JSX? Imagine we've got this component here. It's a user info component. It's going to take a user, and it's going to print out their name and their date of birth. It's using our date formatting our format date function, and it's also going to print out the day of the week, right? So it'll say Bob was born on the 1st of January 1980, Tuesday. Okay, let's see how we do that. So we have our component here, here. And once again, we can set up our test for user info. And it does something. We can render our component, user info. It's going to take a user who has a name and a birthday, which is going to be 1800. That's a long time ago. Okay, 1st of January 1980, and we need some closey majigs on the end. Okay, now when we render a component like this, we can actually get back a reference to the container that it lives in. So this is just sort of the div that the testing library renders the component inside. And then we can just run a test like we did before to see what's in the container. So we can say expect container to have text content, and we don't know. And we run that test, it's going to fail, hopefully. And instead of returning question mark, it actually returns Bob was born on the 1st of January 1980 on a Tuesday. Okay, so we can do that, and we can say it renders the user's birthday or something. Okay, so that works fine for this particular case, but this is a very simple case, right? We're just rendering text content. What would we do if we had like buttons and radio buttons and all of the other nice things that we like to put on web pages in there as well? I mean, we could go through and check for them all one by one, but that is going to be a bit of a pain, especially when we don't really know what's supposed to be happening. So instead, we have another tool available to us, and that tool is Snapshot Tests. If you're not familiar with Snapshot Tests, the way that they work is that first, you write a test and you run your test, and the first time that you run your test, it generates a snapshot. And a snapshot is a text representation of your component as it's rendered. We'll have a look at one in a minute. And then you go ahead and you make all your changes, you do whatever you need to do, and then you run your test again. And when you run the test again, it generates a new snapshot, and it compares the old snapshot with the new snapshot, and it tells you if anything has changed. All right, so it's a really good way of finding out if we've changed stuff. All right, so what does that look like? It actually looks a lot like this, so I'm going to copy and paste. Oh, I don't need all of that, just this one. So here, instead of it rendering the specific thing, we can just say it matches the snapshot. And instead of passing in this specific text content, we can just expect it to match snapshot. And now when we run our test, we get this little thing here that says one snapshot written, And we can actually have a look at that snapshot. We get this directory called underscore underscore snapshots underscore underscore. And inside that, we have a file that's got the same name as our test file with .snap on the end. And if we open it up, we can see there's our component in all its glory, rendered as is rendered in the test. If we then jump back to our test, say, and change something here, turns out actually Bob was born on the 2nd of January, and we run the test again, this time the test is going to fail because the new snapshot no longer matches the old snapshot. And it's going to tell us here that it was expecting the 1st of January, but actually we got the 2nd of January, and it was expecting Tuesday, and actually it was Wednesday. So we can see everything that's changed between the two versions. Now we know that this has changed because we literally just changed it in the test, so we're kind of okay with it. So down here you can see inspect your code or press U to update the test. So we'll press U. And if we go back now and look at our snapshot, we can see that it's updated from Tuesday to Wednesday, from the 1st to the 2nd. And now this is what will be used for all future tests. So now we've got our snapshot test in place, we can go ahead and actually do our refactor, which is very similar to the previous one. We're going to see format, we're going to pass in, oh actually we need to wrap this in a new date because moment takes strings, but format date functions only takes actual dates. And again, the formatting string is different because why would they be the same? And then our test passes again. So we've done our refactor. Okay, cool. So snapshot tests are super handy for things like this, but they do have some limitations. The first is that they don't provide as much information as your more sort of standard test. So you can imagine we've written this component called increment, and we're testing it with the snapshot test on the left there. So in our snapshot test, we render the component, and then we expect it to match a snapshot. Then we press a button, and we expect it to match a snapshot. There's not really any information about what's going on there. Whereas the second version of the test, we render the component, and then we expect it to render the number 4, which happens to be the number we passed in. And then we click the button, and we expect it to render the number 5. So we can see from this that we're clicking the button, and it's incrementing the number. There's a lot more information there. The second limitation of snapshot tests is that they don't actually render everything that you might need. So imagine we wrote this component called clickymajig. Clickymajig renders a checkbox. When you click the checkbox, it waits 2 seconds, and then it unclicks the checkbox. It's probably very annoying. You probably shouldn't ever do this, but if you do, you should write a test for it. And you could write a test like this using snapshot tests, where we are going to turn on fake timers because we need to have that 2-second delay. We're going to render the component. We're going to click the checkbox, and then we're going to expect it to match the snapshot. Then we're going to wait 2 seconds, and we're going to expect it to match the snapshot again. And this test will pass. This test will pass even if you take out the wait for 2 seconds. This test will pass even if you remove almost everything out of the component. There's not a lot you can do to make this test fail. And the reason for that is that when this renders the snapshot, it looks like this, right? So it's a snapshot that says there's an input and it's of type checkbox. It doesn't give you any information about whether that checkbox is checked or not. So we're not actually testing the things that we think we're testing there. And the third limitation of snapshot tests is that you can't do TDD with them. Now you might say, I hate TDD, and fine, don't do TDD. And you might also say it doesn't matter, we're refactoring stuff, we're not doing TDD, and that's true, but if we're refactoring stuff, it's because we're about to make a change, right? Which means that we're going to start wanting to write tests. And snapshot tests just aren't a really good base for writing our new tests on top of, right? Because they don't have that clarity, they don't have that information. But they are really good in specific situations. So snapshot tests are really great. If you have a big component, there's a lot going on, you don't want to write individual tests for every single thing because you maybe don't know what those all are. As an example, that function that I showed you at the start that I didn't refactor, that was in a component that was like 2,000 lines long. My team were working on it. We're pulling stuff out into new components and stuff. We don't want to write a test for every single thing that can happen in that 2,000 lines, right? So that was a really good use case for snapshot tests. The other thing I find they're handy for is, oh no, you'll never know. The other thing I find them handy for is things that have got a lot of presentation logic. So by that I mean stuff like tables, right? I don't know if you've ever tried to write a test for a table using the testing library. you end up writing stuff like, I want to check the value on the 3rd row in the 4th column. And your tests are sort of as opaque as snapshot tests anyway, and they're quite brittle because they're relying on numbers and stuff everywhere. So in those cases, snapshot tests have a lot of value, and they don't really have any disadvantage. So that's a good use case for them. All right, so now we've gone through all that. We've got our tools ready. Let's have a look at a demo. Now we're going to have an app called the Old Farm Shop. Now this is important. This is what you need to remember. This Y in this is pronounced th. In Old English, we had a bunch of extra letters, right? 26 was not enough. Old English had heaps of letters, including one called thorn, which was pronounced th. When the Dutch came along with their printing press, they only had 26 letters, and they were like, you don't need all those extra letters. Just use TH instead, like we do. So we lost all these extra letters. We had to only use the 26 that we have today. But one of the things that happened was that the letter thorn actually looks a lot like a letter Y, and so people kind of use the letter Y instead. And the important thing is that this doesn't say ye olde farmy shop. It says the older farmer shop. If you remember one thing from this talk. Okay, so the farm shop. We don't need that. It looks like this. We're selling farm products, unsurprisingly. So you can buy some corn. You can buy your corn as seeds or as seedlings. And you can see that as you choose the different types, you get a subtotal down here. And you also get your postage calculated. For seed packets, the postage is a flat $8, no matter how many you buy. For seedlings, the postage depends on how many seedlings you buy. The postage is also calculated via a separate service that we have to call asynchronously. All right, so we have some new requirements for our farm shop. And the requirement is that we want to start selling a new product type, which is a full-grown plant, right? This is for people who are like, I really want to have homegrown corn, but I don't want to go through all the effort of like growing corn, so I'm just going to buy like a whole corn plant. I have no idea if that's how corn works, but it seems fine. So we need to show the radio button that says plant. We need to show a new unit and price, and we need to show a new amount for postage. All right, so this is what it's going to end up looking like. Now, if we were to implement this, we could just implement it in the order that we're given there, but that's not how I would do it. And the reason for that is that if we start with the radio button and implement that first, we've got to do the whole lot in one go, right? Whereas if we start with making sure that the label can handle plants, then we can just write the code that manages the label. We can merge that, we can deploy it to production, and it's fine, it doesn't matter. So we can break this into small pieces. And then we do the radio button last, and it acts kind of like a feature toggle. It means that we can break our change up into smaller pieces. You could argue that this is such a small change that who cares, it doesn't make any difference. And you might have a point, but I'm the one with the keyboard, so we're doing it my way. All right, so this is our component that renders the page. There's a lot of stuff going on. We're not going to look into all of it. But this here is the part that renders the actual label, right? You can see there's a lot of repeated code there. There's a bunch of stuff that's hard-coded that probably doesn't need to be. And TypeScript is mad for some reason about count. So to me, this says that this code could be refactored, right? We could pull this out into its own component, write some tests around it. It'd be way nicer. So we're going to do that. But of course, we're not just going to start changing things without any tests. We're going to write some characterization tests first. So let's create a test. So we're going to test the product component. Now there's 4 scenarios that we need to test. One is with seed packets selected with no amount entered, seed packets selected with an amount, seedlings selected with no amount, and seedlings with an amount. That's basically all of the things that can happen on the screen. And for this, because we've got a big component, there's a lot of stuff going on, this to me is a really good use case for snapshot tests, so we're going to do snapshot tests. So, no, what do I need? Let's start with a describe. Okay, so describe when seed packets is selected and no amount is entered. It matches the snapshot. Okay, so we're going to grab a reference to the container. We're going to render our component, which takes a prop of product, which is just the name of the product. Import that from there. We want to select the radio button. So seed packets equals string.get by role. It's a radio button, so role is radio. There's a couple of radio buttons on the screen though, so we need to give it a name as well. And then we can just click that. Not double click, just one click. Seed packets. And then we can expect the container to match the snapshot. It's just mad about screen there. There's a global variable called screen that VS Code thinks that is, and it's not. So then if we run this, we have our snapshot written. So that's nice. Okay, so we need another one of those for when we enter an amount. And an amount is entered. We're going to grab the amount input. Now the amount input is an input of type number. So obviously the ARIA role is spin button, because who even knows? Amount input, and we're going to grab 4 of them. All right, and now we can expect that to match the snapshot. Cool. And then we can do the whole thing again for seedlings. So we'll just copy those. We would change this to seedlings. No. And the same down here. Oh, I should have just renamed it, shouldn't I? Oh. I use IntelliJ at work all the time, so I've forgotten all the VS Code shortcuts. Okay, so we run that. We get all of our snapshots written. Everything's good to go, except if we scroll up here, we get this warning that says an update to product inside a test was not wrapped in act. Now, the reason that this is happening is if we look in our product here, when we change the amount, it fires off this handle function, or this use effect, which fires off this calculate postage function. The calculate postage function, if the product type is seed packets, it just returns immediately because seed packets have got a hard-coded postage amount. When the amount is 0, it just returns 0. But when the seedlings is selected with an amount, it needs to go off and fetch the postage from another service. So our test runs, we change the amount, this gets fired off, then the test finishes, and then this returns, and then the state inside the component updates. So the component state is updating after the test is finished, and React is kind of gone, that's probably not what you intended. And it's absolutely right, that is not what we intended. So thank you, React, or testing library, whoever it is that came up with this error. Warning. So the way that we can fix that is that we can just make sure that we wait for the postage to be updated before we let the test finish. So we can grab a reference to the postage. It says something like postage. And we can wait for, expect postage to have text content. And it's going to be, I think, postage equals $32. Okay, so now when we run this, it fails. Oh no. Oh, because we've made this, we've got an await, now this needs to be async. All right, so now when that runs, the snapshot doesn't match anymore. But the reason it doesn't match anymore is because previously the postage was 0 because it hadn't returned yet. And now we've actually got the postage value. And because we've got the postage value, the actual amount has updated. Right, so we've waited for that update, and now we're OK. Cool, so now that we've done that, we're ready to actually do our refactor. So if we jump back in here, I'm going to pull out this label into its own component. I'm just going to do it in the same file, just because it's going to be easier for copying and pasting, but you can do it in a separate file if that's how you like to roll. And I'm just going to grab all of this. Nope. Whoever put the page down key right next to the arrow key like that clearly has skinnier fingers than I do. And we can chuck that in here. Now there's a couple of problems here. Like we need access to this product type. So let's pass that in. And count as well. So we'll pass both of those in. Now we look at this. This code is just like a repeating block with sort of a bit of hard-coded name in here. So I reckon we can get rid of that hard coding for a start by pulling the names out here. It's going to be seed packets, and seedlings is going to be seedlings. So now instead of having this, we can have names, product type. And the same here, instead of having prices seed packets hard-coded, we can have product type, and down here as well. So now we don't need the 2 labels, right? We can just have 1. So we can get rid of all of this. And if we put that back up there, it'll auto-format for us. Cool, so now our label component is nice and refactored, and we can stick it in here and use it. And we need to pass in the product type. Oh, come on, autocomplete. You're letting me down. And we can get rid of all of this. Isn't that nice? OK, so now when we run our test, we'll see that our snapshot failed. Because we didn't update it before. Oh, no, how embarrassing. OK, so now we've updated it, and everything is OK. There is sort of one thing here, though, that we've missed, a dependency between our components, is that this HTML4 value here needs to match the ID on this input. There's a couple of ways we could handle that. We could pass in like an ID prop into the label that we could use. We could just assume that we're going to do it right. But what I would do is just sort of accept that these 2 components are very tightly coupled and just make them one component. So I would, instead of this being a label component, it's going to be a number input component. Instead of just a label, it's also going to have all of this. So that can all go in there. Now we need something wrapping this, and you could use a fragment, but the actual original thing is using a div, so I'm going to use a div. That's all going to work there. And then we just need to pass in this handle count change. Handle count change is kind of a weird name for a prop, so I'm just going to call it onChange, because that's what you would call it normally. And we can call it onChange down there. Right, so now if we jump up to our component, we can change this to number input. We just need to pass in onChange. And then we can delete this div and all of this. And if we run our tests, we can see that everything still passes. Our refactor is all good. So now we've refactored it. We're actually ready to start making our change. Now, we could just jump in and make the change. But again, like I said earlier, I don't like snapshot tests for doing TDD, but I do like to do TDD. So in this case, I would spend a bit of time going back and writing tests actually for this component, for the new number input component. Even if you don't like to do TDD, I would still suggest writing extra tests because at the moment, this component doesn't have any of its own tests. It's just relying on the parent component's tests. And that, to me, is a bit weird, a bit untidy. The tests that we would write are almost identical to the tests that we wrote before, so I'll save you all the hassle of watching me write them all again. Here's some I prepared earlier. You can see they're the same scenarios. So when we've got seed packets and there's no number, when there's seeds, there's a number, all of the different 4 scenarios, except this time we have explicit values in here, right? We are expecting the label to say this explicit thing. And we also have an additional test up here just to check that it calls the onChange handler, because that's a little integration that we have to handle now. It doesn't like that because we didn't export the function. All right, so now we export that function, all of those tests will pass. You might argue that that's a bit of a waste of time writing tests for things that we already have tests for, and again, if you don't have the time, then don't do it. But I timed myself writing those tests and it took 4 minutes. So I don't know how busy you are, but I would take the time to write the test. And now we can write the tests for our new functionality. So again, we can just grab the scenarios we have here. And we can say when the product type is plants, and no amount is entered, we're going to pass in type of plants, number of plants. And if you remember, the unit price for a plant was $15, so we can put that in there. And when we have an amount, then it's going to be $15. And as everybody knows, 15 times 12 is, of course, 180. And now we have 2 failing tests because we haven't actually done the implementation for them. So now, finally, we are actually ready to write our implementation. And to be honest, it's a little bit of an anticlimax because we've done all this work to refactor our code. The actual code that we need to write to make our feature work now is pretty minimal. We need to add our plants to our names object here. And we need to add it to our prices object here. And then we can run our tests, and one of them still fails. Who can tell the difference? Oh, it still says seedlings. Okay. Yeah, because this actually should say plants. Okay, and now we have all of our tests passing. So we've, because we spent that little bit of extra time to do that refactor, we've made our actual change very simple. And because we spent the time writing the test, we can be highly confident that this is all going to work as expected. All right, so we don't have time to go through the rest of the changes today, but hopefully that's enough to see what the steps that we need to take to get through them. Okay, so what did we learn today? We learned how to decide if we should refactor or not. We learned how to use characterization tests to make sure our refactors are safe. We learned how to use snapshot tests to write characterization tests for JSX. And most importantly of all, we learned that this YE says the. And that's what a thorn actually looks like in some fonts. All right, so if you wanted to have a look at the slides again, they're at refactorchapter.ez.codes. And the code examples are all up on GitHub, and there's a completed version as well. If you would like to argue with me about this or anything else, I'm on Twitter at Erin Zimmer. And finally, we are hiring at Cash App. So we're looking for engineers across all levels. In Australia, we're mostly looking for back-end and full-stack engineers. It's a fantastic company to work at, really interesting product, heaps of really great perks, and honestly, the nicest bunch of people I've ever worked with. I've never worked at such a big company that cares so much about its people before. If you're interested, have a chat with me, or you can hit us up on careers, and that eyeball is in a disturbing number of places, but apparently it's a thing. I'm sorry. And that's all I had today, so thank you very much.